solved this problem? Can someone tell me it's a standard form? How did you have applied this? So objective function I'll come later. So how did you modify the first constraint? So x plus 2y
x plus 2y plus s1 equal to 40.
Okay. Plus s1 equals 40. Constraint number 2.
4x plus 3y minus s2 plus a2 equal to 60.
Minus s2 plus a1.
Okay, and we give
Yeah, okay. Equal 60. Third one.
Third one 3x plus y
3x plus y
minus s3
minus
plus 8
s3
plus
plus
a2
a2 equals
equal to 0.
Equals 30.
30, sorry. 30.
30. And objective function
Minus 20x maximize minus 20x minus 10y
minus 20x minus
minus
10y
10y plus 0 s1
plus 0 s1
minus 0 s2
minus 0 s2
minus 0 s3
0 s3 plus
a1 plus a2
ma1 plus
a2.
Okay, then what is our initial solution? What is our initial solution? X comma y comma s2 comma
s1
s3 equals 0. Why s1 should I put 0? So s1 is only there in the first constraint. There is no a1.
Yes, sir. Yes, sir.
Yeah.
S1, A1 and A2 will be there. Changing.
Yeah. So S1 equals 40, A1 equals 60, and A2 equal 30. So the variables entering into the solution space is, so the variables entering will be into the solution space will be S1 for the first constraint, A1 for the next constraint, A2 for third constraint. Okay, so S1 value is 0, A1 will be M, and A2 will be M. Okay, yes. So we can follow further. I hope you can solve further. How many of you have solved it? Okay, so this is the next problem. Yeah, so how to proceed?
So new method or
No, first whatever the method is, we have to convert into standard form.
Okay, so the first constraint will be 5x1 plus 7x2 plus 4x3 plus s1
Hmm.
equal to 7.
Okay.
Then second one will be greater than equal to, so minus s2 plus a1 will be there. Then the third one minus s3 plus a2.
Okay. Right.
The
But there
s1
is a
comma.
small, yeah, but there is a small correction in that. Okay. That is RHS of any RHS side of any constraint equation should be positive. Okay.
Oh, okay. So then multiply it to my negative sign, sign change will be there. Then we can
Yeah.
apply
Yes.
plus
Exactly.
s2. Okay.
So you have to keep it in your mind that RHS should be always positive. So your second constraint alone, you need to multiply it by -1 before you proceed. So it will come as 4x1 minus 7x2 minus 5x3 less than or equal to 2. That's the way you have to convert. It is a must before you try to attempt the problem. Okay, then you can convert into standard form. Okay, so convert to standard form. So standard form, if you are converting the first equation as he told, 5x1 plus 7x2 plus 4x3. Okay, so plus s1 equals 7. Second constraint again, 4x1 minus 7x2 plus 5x3 plus s2 equals 2. Third constraint, 3x1 plus 4x2, okay, minus 6x3 plus, sorry, minus s3 plus a1 equals 29 by 7. And you can add the non-negativity constraints as x1 comma x2 comma x3 comma s1 s2 s3 comma a1 greater than or equal to 0. Okay, any, is this is clear?
Sir, one
Is
doubt,
this,
sir. Why we are not considering r as a negative, sir? Why it
which
is
one? No,
RHS cannot be.
that is a what I can say, that is a rule what we have to follow in Simplex. Okay, that is an assumption that we are following in the Simplex.
So
Hmm?
if we don't consider it, will get a error or something?
You will definitely yes, definitely yes.
Okay.
Okay, so sometimes if this is the case, this may this if you keep this as -2, always in the replacement ratio, you will not get this constraint or this row will not never ever enter into the solution space.
Okay,
It
sir.
will be -2 by 1, -2 by 2. Okay, so always it will come as minus only. So it will never ever, this constraint will never ever enter into the solution space. So to avoid that, we are taking the RHS as positive always. So that is a rule which you have to follow in Simplex.
Okay, sir.
Yeah. So rest the conversion is clear. Is the conversion is clear? Any other doubts? Okay, so if there is no other doubts, I'll proceed this problem by two phase. Okay, so I'll solve this problem by two phase. method. So as the name says, there are two phases of problem solution you have to employ here. Okay, so first is phase 1 and next is phase 2. Phase 1 we call it as auxiliary LPP. Okay, so auxiliary LPP. And phase 2 will be your actual problem. Okay, so what do you mean by this auxiliary LPPs? Auxiliary LPP will have an auxiliary objective function. Okay, it will have an auxiliary objective function. Okay, consist of only artificial variables. Okay, only artificial variables. Okay, and subject to the constraints. And subject to the constraints of your problem. Okay, you have to solve the constraints. Okay, you have to solve the constraints and this auxiliary and this artificial variable. Okay, and this artificial variable will get removed from the problem. Okay, artificial variable will get removed from problem. Okay, so when artificial variable get removed from the problem, you can go for phase 2. Okay, you can go for phase 2. So phase 2 will have your actual objective function. Okay, actual objective function without auxiliary variable. Okay, or without your artificial variable. Okay, plus reduced constraints. Okay, reduced constraint from phase 1. Okay, here when you solve with auxiliary LPP, your constraints are modifying. So that modified constraint you have to use in phase 2 with actual objective function. This is how we will proceed a problem in two-phase method. Okay, so for the given problem, okay, so for given problem, how many artificial variables do we have? How many artificial variables do we have? How many
One,
artificial
sir.
variables? We have only
One.
one. So auxiliary LPP objective function will only have this artificial variable alone. So if you take the homework problem, there are two artificial variables are there. So that two artificial variables you need to take into account. Okay. So the phase 1. So in the phase 1, you will have auxiliary LPP. Okay. So objective function will be, maximize z equals minus a1. Okay, if one more is also there, it will be minus a2. Okay, so minus a1, then subject to the constraints. Okay, so subject to constraints, you have all the three constraints. So constraint 1, constraint 2, constraint 3. All the three you have to take into account. Okay, all the constraints are there in the page number 1. So refer page number 1. So for your reference and thing, you can just take a screenshot of the problem and you can just take a screenshot of this values given over here. Okay, just take a screenshot and keep it for your reference right now. Done. Okay. So now I need to prepare the same simplex table. You have CJ product mix solution constant 10 x1 x2 x3 x1 x2 x3. So you have CJ here, you have product mix here, so you have solution constant here, so x1 x2 x3, you have s1 s2 s3, and you have a1, and here you will have replacement ratio. So auxiliary LPP, I had only term minus A1. So the objective coefficient of x1 will be 0, x2 will be 0, x3 will be 0, s1 will be 0, s2 will be 0, s3 will be 0, and a1 will be minus 1. Okay. So what will be the variable under product mix which will be entering into solution space initially? What will be the variable?
Sir,
So
x1, x2, x3. No, S1, S2, S3.
S1,
S2, S3.
S3.
Wait, sir, 1 second, sir. Oh, no, sir. S1, S2, A1.
Yeah. So it will be S1, S2, A1. Okay. So under product mix, the variables will be S1, S2, and A1. So value of S1 as 0, value of S1 as 0, S2 is 0, and A1 is minus 1. Okay, so you can see over here, from here I am writing. So solution constant, RHS side of your equation, it is 7, 2, and 29 by 7. 29 by 7. So first constraint, it is 5, 7, 4, 1, 0, 0, and 0. Second constraint, it is 4, minus 7, minus 5, It is 0, 1, 0, 0. Third constraint, it is 3 is 29 by 7, then 3, 3, 4, minus 6, 0, 0, minus 1. Okay, 0, 0, 0, minus 1 and 1. Now what we have to do?
Find Zj.
Yeah, you have to find Zj. Okay, so calculate Zj and then calculate either Zj minus Cj or Cj minus Zj. Any one of the term you can calculate.
Sir, Zj for the first x1 will be minus 3, sir.
1 minute. Which one you are asking? Zj for?
X1, sir. X1 is minus 3, no?
Yeah, Zj for x1 is minus 3.
Minus 3 by minus 4, 6 like that.
Yeah, so that will be, yeah, so it will be minus 3, minus 4, it will be 6, 0, 0, 1, minus 1. Okay, so Zj minus Cj also, this will be minus 3, minus 4, 6, 0, 0, 1 and 0. Okay, so which is our key row? Aditya Shivakumar, which is our key row? Aditya Shivakumar, is there? Aditya Shivakumar, Aravind Prakash, Aravind Prakash,
Sir, minus 4, I think so.
hmm?
I think it is minus 4.
What do you think? You have to confirmly tell.
It's minus 4 only because it is the lowest value.
Yeah, okay. So the minus 4, okay, and the corresponding row, the corresponding column will be your key column. That is what we are following so far. Now find the replacement ratio. So it is 7 by 7. It is 2 by
What?
minus 7 and 29 by 7 by 4. Which one? Which is a key row?
Second one. Second one.
Second one. Why?
Because there is a negative symbol is there, no, sir. Because
So
it will be
what?
the lowest rate.
So what? key row is only, so key row only lowest positive or 0. Okay, no negative business. No
Okay.
negative business. Okay. So the key row will
So
be first
one.
1. Okay. The key row will be 1. So 7 will be the key number. So x2 will be your entering variable and s1 will be your departing variable in the next iteration. Okay. So please solve and get me the next iteration. Make it fast. Please solve and get me the next iteration. Make it fast. I have kept it over here. Please solve and get me the next iteration. Five minutes of time. Please solve and get me the next iteration. We can take a screenshot of the present slide and please do go for the next iteration. So I will not solve it. You have to solve. Those who solved it, please submit it in the chat. Yeah, okay. What happened? Whose mic is open? What happened? Get me the first row data.
1, 5 by 7.
1. Okay.
No,
5
that
by
is x1. No,
which
sir.
one?
X1's value is 1. Under x1.
Under
That is
X1. No.
solution, no, that one, sir. The heading is solution. I didn't find the solution. For x1, it is 5 by 7.
X1 is 5 by 7.
No, x1 is 1. Sorry.
X1 is 1.
Yes, x1 is 1. Then x2 is 5 by 7. I don't know, sir, whether it's right.
No, no, no. What is the value under? Okay, so yeah, so what is the okay, so x1 is, so under solution constant the value is 1. Why? It is 7 by 7. 7 by 7, 1. X1 is 5 by 7. X2 is again 7 by 7. X3 is 4 by 7. S1 is 1 by 7. S2 is 0 by 7. Okay. S3 is also 0 by 7. And A1 is also 0 by 7. I will write only the values over here. So the next row it is 9. Next is also, you can check any value differs. We can check. It is minus
The
1.
formula is 7 minus that 7 minus then that coefficient of whatever it is into 1, no?
Here. Here you are asking.
Yes, sir.
Under
S2 and
solution
A1.
constant. It is 2 minus minus 7 into 1.
2 minus minus. Okay, sir.
Okay. So 2 minus minus 7 into 1. 2 is from old table, minus 7 is also from old table, 1 is from this table. 2 is the old value in the same, under same row and column, same value. Minus 7 is the corresponding element in the key column. 1 is the reduced element in that particular column. Still any confusion exists? Minus 1. Please solve it. 0 and 0. So this will be old value is 29 by 7 minus, what was the intersecting element in the previous table? It is 4, and reduced element is 1 over here. So 4 into 1. So value is 1 by 7. This is also 1 by 7. This will be 0 minus 58 by 7 minus 4 by 7, 0, minus 1 and 1. Set J is minus 1 by 7. Here it is minus 1 by 7, 0, 58 by 7, 4 by 7, 0, 1 minus 1. Zj minus Cj, this is minus 1 by 7, 0, 58 by 7, 4 by 7, 0, 1, 0. Do we need to go for next iteration? Do we need to go for next iteration?
Yes, sir.
Okay. Which is the key column?
Uh, X1.
X1. Okay, right. Okay, now find the replacement ratio. It is 1 divided by 5 by 7. So it is 9 by 9 and 1 by 7 divided by 1 by 7. So this is 7 by 5. This is 1 and this is 1. How to proceed?
Two columns are same, no, sir.
Yeah. Now you can see over here it is tie.
Replace both.
Hmm?
No, no, we can't.
No, you can't replace
Replace
both.
both.
You can replace you can replace only one. How can you replace 2x1 over there? Then which x1 solution will you take? So basically there is no tie breaking rule. If a tie comes to a problem, there is another terminology is there that I'll teach you in the evening class. I'm not going into right now. So we will solve this first, then I'll discuss with you that if tie comes, how the solution will behave, etc. in the evening class, not with respect to this problem. Okay, so basically there is no tie breaking rule. There is no tie breaking rule. Okay, you can select anyone. You can select any row. But in this case, it is different. Which term we want to get eliminated?
A1, sir, because it doesn't have any involvement in the
Yeah,
maximization.
yes. Okay, but in this case, A1 needs to eliminate. So select it. So select it as your key row. You are correct. Okay. When you select that, you got your key row, key column. So key number is also got. So go for the next iteration. Iteration number 3. Go for the take a screenshot of this and solve. Go for the iteration number 3. See, everybody please practice it. That is why I am giving you time. If I just run in PPT, I can finish off the things like anything. Please practice.
Okay, sir. Sir, this also you upload, sir.
Which one?
This presentation also.
I will upload everything after today's evening class. Don't worry.
Okay. Sir, is today today evening the last class, sir? Tomorrow and after tomorrow P1.
No, tomorrow class is there. We have our regular classes.
Oh, okay, sir.
Please take a screenshot and solve.
Sir, from 25th to 3rd is a holiday, no, sir?
Yeah, that is holiday. I hope you have taken the screenshot. X2 here. Yes, 2 here. Here. CJ. 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 So all the terms here are 0. So solution constant is 2 by 7. It is 0. It is 1. 0. 1. 42. 3. 0. 5. This is 0. S2 is 0. 0. 521. 37. 163. 1 1 1 0 minus 58 minus 4 0 minus 7. Okay. So end of phase 1. So when you solve the previous iteration, you will end up with like this. Okay. Since all Zj minus Cj's are either zeros or positive, that is your termination. So this is a place where we have stopped in the morning. So we have calculated all Zj minus Cj. So your Zj minus Cj is 0, okay, or positive. So I terminated the iteration. Okay, terminated the iteration. Okay, so iteration ending, that is the end of phase 1. Okay, now you have to be taken care here one thing. Now when the phase 1, if you are ending, we have to ensure that no artificial variable is present under the solution under this product mix column. No artificial variable. If artificial variable exists in the problem, at the end of your iteration, or at the end of your iteration, the complete iteration, you can say that the problem will not have any solution. That is, if the artificial variable is completely eliminated and all Zj minus Cj becomes either 0 or positive, I can terminate the iteration of phase 1, and then we can move to phase 2. So phase 2 will start with the same constraint. Okay, whatever I have written over here as the constraint, okay, whatever I have written over here the constraint, these constraint values you need to copy for phase 2. Don't go back to your original problem. So from the original problem, we have modified the constraints in such a way that the presence of artificial variable will not exist in my problem. That is why I have removed A1. I didn't even bother to calculate A1 here. Okay, and I am going for phase 2. You can calculate it and you can cross verify also. You can see to that also you will get it as 0. Okay. So in the iteration number, so in the phase 2, first iteration, we have to consider the same variable, the x2, s2, x1. So that is what we have entered, x2, s2, x1, 2 by 7, 0 and 1. So that is written here, 2 by 7, 0 and 1. All the same column, the same reduced equations I have taken. Now here only thing is that in the phase 1, all the variables here are 0 and a1 alone is minus 1. So in phase 2, I have to consider my actual objective function. So actual objective function is something like 3x1 plus 2x2 plus 2x3 plus 0s1 plus 0s2 plus 0s3. Okay, so that is my actual objective function. So the x1 coefficient is 3. I'll write 3 here. Then next it is 2. This is also 2. S1 is 0. S2 is 0. S3 is 0. A1 I have already eliminated from my problem. So no need to bother about A1. So now the x2 is having a coefficient of 2. So I have ended 2 here. And S2 the value is 0. So I just entered 0 here. X1 coefficient is 3. So I have entered 3 here. Okay. Now I can calculate the ZJ value. Are you clear? I have in phase 2. Okay. I have started with reduced constraint. Okay. Reduced constraint. Okay. At end of phase 1 plus actual objective. Okay. So actual objective function is taken into the problem. Is that clear? Is that clear? Now I need to calculate the ZJ the same way. 2 into 2 by 7 plus 3 into 1. So you will get it as 25 by 7. 25 by 7. This will come as 3. Next is 2. Next is minus 90. Next is minus 6. Next is 0 and minus 11. So Zj minus Cj, if I calculate, this will become 0, this will become 0, this will become minus 92, this will become minus 6, this will become 0, and this will become minus 11. Okay. Now tell me the what should I do next? What should I do next? Problem, can I terminate? Can I terminate the problem?
No, sir.
No. Okay, so I have to go for next iteration. So tell me which is the key column.
Sorry, X3, sir.
X3. Okay, so you have got the most negative coefficient of minus 92 in X3. So X3 will become your key column. Okay, so now calculate the replacement ratio. So replacement ratio will be 2 by 7 by 42. So 2 by 7 by 42. Likewise, you can calculate. So that will become 1 by 147. So 1 by 147. Okay. So this will become 0. So 0 by 521. So that is 0. The next is minus 1 by 58. Now, which is my key row, which is my key row.
S2, sir.
Yeah, okay. So I told you we have to consider the lowest positive, that in lowest positive or 0. So S2 is my key row. Okay, and my key number is 521. Okay, key number is 521. Okay, and the correct. Okay, so I had to go for the next iteration. So please solve the next iteration. First, reduce the key row by dividing all the elements with key number. So next row, if I go the under product mix, you will have x2, you will have x3, you will have x1, and x1 is 3, x2 is 2, and x3 is also 2. So divide by key number, the solution constant x3 becomes 0. So next is also 0, next is also 0, 1, 37 by 521, 37 by 521. This is 1 by 521. Next is 63 by 521. So for the other row, for the other non key rows, so the values will be, so the first one is 2 by 7 minus 42 into 0. So that is 2 by 7. Next is 0. Next is 1. Next again is 0. Again is 9 by 521. Next is 42 by 521. Next is 41 by 521. And while coming over here, that will be 1 minus 58 into 0. So that will be 1 here, 1, 1, 0, 0, 62 by 521. Next one, 58 by 521, and 7 by 521. So the ZJ, it will be 25 by 7, 3, 2, 2, 278 by 521, 92 by 521, and 65 by 521. So when I calculate ZJ minus CJ, you will get 0, 0, 0, 278 by 521, 92 by 521, 65 by 521. What's next? What's next? Shall we need to go for next iteration? Shall we need to go for next iteration?
Sir, a small doubt, sir. Under S2, no, sir.
Yes, please.
Sir, under S2 for ZJ, will it be 84 plus 286 plus 174? Will it be 260 by 521 for ZJ?
S2.
Yes, sir. Under S2 for ZJ.
Under S2. Okay, how much it is?
2 into 42, that is 84 plus 86 plus 174 by 521. So will it be like 260 by 521?
Okay, right. So okay, I can I have to check. Okay,
Okay, sir. Okay.
I'll check and okay, no issues. So it's a positive value. Hello,
Yes, sir.
it's a positive value.
Yes, sir.
How much? 2
260, sir.
260.
Yes, sir.
So you can check.
Sir, that is 58 by 521, right? No, sir.
Yeah, yes.
Okay, sir.
Okay. Now what's the next step? What is the next step? Can we stop here? Or is it to proceed to next iteration? If you want to proceed to next iteration, please let me know which is the key column.
Sir, you will terminate here, no, sir?
Yeah, so we can
Sir,
terminate here. Since all
because
Zj minus Cj are either positive or zero, we can terminate phase 2. Okay. Since all Zj minus Cj are either positive or zero, we can terminate here. Okay, now what is the solution? Maximize Zj equals 25 by 7. Okay, we can see over here x2 is 2 by 7. X1 is 1 and x3 is 0. Okay, is that clear? Any doubts? Any doubts? Any doubt in this problem? Anything is not clear? And you have the freedom to either use two-phase method or bigger method. It is up to you. Okay, we will not specify any methods to you. You have every freedom to choose your method and you have to solve. Both will end up in the same result. Any doubt? Is the steps are clear? Is the steps are clear? I'll just give you another problem. You can also try. So maximize z equals 5x1 plus 3x2 subject to the constraints 2x1 plus x2 less than or equal to 1. x1 plus 4x2 greater than or equal to 6. x1 comma x2 greater than or equal to 0. You can take it as your work.
Sir, which method, sir?
Any method. You try two-phase method. You practice for two-phase method. Don't go into bigger.
Okay, sir.
This one you try for two-phase method. Don't go for bigger. Okay. Just for a practice. Right? You can take a screenshot. You can take a screenshot. Taken? Okay, now I'll just go back into the PPT. So this is the previous slide, whatever we have seen. So this was your yesterday's homework. I just shown you how to convert it, and you might have solved, and some of you have submitted it on the chat box in here. Good. It's a good practice. Okay. At least some of you are trying. Good. So we'll move to the next problem. So important points regarding the artificial variable. Point number 1, ensure that the RHS is greater than or equal to 0. Morning we have done a problem by converting the RHS equal or greater than 0. We have converted a problem, we have converted a constraint and seen how it has to be done. Next thing, lesser than constraint, add slack variables. The slack variables qualify for the basic feasible solution. Greater than constraint, add surplus variable. It's not adding, it's basically subtracting surplus variable. Surplus variables do not qualify for the basic feasible solution. In such case, add minimum artificial variables to get the basic feasible solution. Don't add artificial variables just to add it. Do only if there is no basic feasible solution exists. Okay. There's a third case. Equality case is also there. Equality comes. Please add only artificial variable. Don't add any slack or surplus variable to it to solve the problem. Okay. And if artificial variable you are adding, you will have the freedom to choose bigger or two-phase method to solve the problem. We will not give you any specific instructions regarding like that in the questions. Okay. So this is the case. Finally, ensure that the optimum solution does not contain the artificial variable. So initialization, iteration and termination, please be careful in that. So it is simple mathematics only. You are either adding, subtracting or multiplying. Okay. So plus or minus sign when changes one in one of the point, then your entire iteration will wrong. You will end up in a wrong result. So please be aware of that and please solve the things properly. Yeah, so and another question is given right now here is to maximize z 4x1 plus 3x2 subject to the constraints. Okay, less than symbol. So how will you modify it? Jashwant Raj. Jashwant Raj available? Jashwant Raj K is there? Jashwant Raj, are you there? Kailash L. Kailash L.
Sir, yes, sir.
Yeah, Kailash, can you just tell me how to what to be done as a next step?
Sir, your screen is hiding. Sir.
Now it's visible.
Yeah, yes, sir. Sir, we have to create the maximize functions.
Okay.
The variables S1 and S2.
Please let me know how to convert it into the standard form.
How to add plus 0 S1 plus 0 S2.
Okay. Constraints.
Sir, yes, sir. 2x1 plus 3x2 plus S1 equal to 8.
Okay, right.
3x1 plus 2x2 plus S2 equal to 12.
Yeah, correct. Correct. Okay. Now, what is the next step? Nirmalanandan KV. Nirmalanandan.
Sir, hello.
Yeah, you are audible. Please let me know what is the next step.
Sir, next up, it's first iteration.
Next step. What is the next step?
Sir, we have to draw the table, sir. Initial
Draw
conditions,
the.
sir.
What are the initial conditions? How do we get the initial conditions here?
Sir, this
By keeping x1 and x2 as
x
0.
0 will substitute value.
Yeah, we get s1 equals 8 and s2 equals 12. Yeah, correct. So I prepared the table here. So variables are written, constraints are written. Okay, calculate Zj minus Cj or Cj minus Zj, whatever you want, you can calculate. Identify the key column, find the replacement ratio, and
Yes.
now you can, yeah, okay, Nirmalanandan. So you can see over here, there is a tie comes. What to do? It's open to all. What to do if a tie comes? No artificial variable present here. Both are slack or surplus. So no tie breaking rule. You can select any one of this arbitrarily. You can choose S1 or you can choose S2. It is up to you. Okay, whatever you choose, it is correct. Okay, no tie breaking rule in these cases. If artificial variable is present, you can go for artificial variable. Okay, if not, you can choose anything arbitrarily. So I have choose for replacing S2. So S2 is replaced by X1. Done the iteration. Again, Cj minus Zj, I got a positive here. So positive value, again for that I have find out the replacement ratio. So 0 and 6. So 0 is the lowest value. Okay. So the lowest value is taken, gone for the next iteration. Okay. So in that case, S1 is replaced by X2. So I did the second iteration. Yeah. Now what happens? Now what happens?
Sir, termination, sir.
Okay. What about the result? What about the result?
Sir, I think ZJ is 16, sir.
Okay.
Then X1 is 1.
No. The last
X1
column is
is 4, sir,
RHS
and
here.
X2.
This is here. This is here. The last column RHS is here.
Yes, sir. X1 is 4
Okay.
and X2 is 0, sir.
Yeah. But you see the previous iteration. What happened? You see the present iteration. What happened?
Same repeated, sir.
Yeah, same repeated results are appearing. Here also x1 is 4, s1 is 0. It means s1 is a non-variable, no need to consider. Here it is modified, x1 is 4, zj is 16, and again x2 is 0. So you can see that is a problem which is having two solutions right now. The not two solution, same solution is existing. So if we compare solution 1, x1 is 4, x2, x3, x4 all are 0 and z equals 16. x3, x4, please note it as this is s1 and s2. This is S1 and this is S2 and Z is 16. Solution number 2, again x1 4, x2 equals, x3 equals, x4 equals 0. Now, when you end up doing more than the required number of iteration, the present condition, whatever we have obtained, that is called degeneracy. Okay, degeneracy is the one like this, where a tie is coming and you are ending up with the same results. Okay, you are ending up with the same results in two iterations. Then that problem is called degeneracy or degenerate. Okay, the problem which I given to you right now is a similar one. It is a degenerate problem. The homework problem what I given to you as two phase, it is a degenerate problem. It will end up with phase 1. You cannot able to proceed to phase 2. When you solve it, you will get it. So once you solve it, we will have a discussion more on that. So this is a situation called degeneracy. Degeneracy normally occurs if you are not modeling your problem properly. Degeneracy will occur. So a problem you have to ensure that when you are formulating a degenerate problem should not exist. Okay. So when there is a tie condition in the theta value, then degeneracy. So theta I have not taught you. We have seen it only solution constant. So when there is a tie in the replacement ratio, okay, in the replacement ratio, then degeneracy will occur. So degeneracy can happen in the middle of the iteration also. Okay. Degeneracy do not prevent you from getting an optimal solution. Need not to be. If it comes sometimes in the middle, you may go in loop and you will not able to get the solution. So in case of tie, we can use a minimum subscribe rule, but it's not necessarily that you will avoid degeneracy. Okay, degeneracy is a limitation of the simplex model. Okay, that you have to simplex model. Degeneracy is one of the limitation. So this is what will happen when a problem becomes degenerate, or sometimes there will not be no solution. You will not able to get even after certain iterations. So that is also a degenerate problem. In all the linear programming problems, almost all models, the degeneracy will going to come. We will discuss when we are discussing about transportation, how the degeneracy will come in transportation. We will discuss. It will not be like this. It will be varying. And these are the things which you have to be look into it when you are terminating a simplex problem. Alternate solution, okay, unboundness, infeasibility, and cycle. Alternate solution means not like degeneracy itself. Okay, there may be some other optimum also which is equally and likely good, that also will happen. Yeah, so this is a simple problem for alternate optimum.